Now, let's move on and look at our next algorithm, which is logistic regression. Now, in order to understand why we use logistic regression, let's consider a small scenario, all right? Let's say that your little sister is trying to get into grad school and you want to predict whether she'll get admitted in her dream school or not, okay? So, based on her CGPA and the past data, you can use logistic regression to foresee the outcome. So, logistic regression will allow you to analyze a set of variables and predict a categorical outcome. Since here we need to predict whether she will get into a school or not, which is a classification problem, logistic regression will be used. Now, I know the first question in your head is, why are we not using linear regression in this case? The reason is that linear regression is used to predict a continuous quantity rather than a categorical one. Here we're going to predict whether or not your sister is going to get into grad school, right? So that is clearly a categorical outcome. So when the resultant outcome can take only classes of values, like two classes of values, it is sensible to have a model that predicts the value as either 0 or 1, or in a probability form that ranges between 0 and 1. Okay, so linear regression does not have this ability. If you use linear regression to model a binary outcome, the resulting model will not predict y values in the range of 0 and 1, right? Because linear regression works on continuous dependent variables and not on categorical variables. That's why we make use of logistic regression. So understand that linear regression was used to predict continuous quantities, and logistic regression is used to predict categorical quantities. Okay? Now, one major confusion that everybody has is people keep asking me, why is logistic regression called logistic regression when it is used for classification? The reason it is named logistic regression is because its primary technique is very similar to linear regression. Okay, there's no other reason behind the naming. It belongs to the general linear models, okay? It belongs to the same class as linear regression, but there's no other reason behind the name logistic regression. Logistic regression is mainly used for classification purpose, because here you'll have to predict a dependent variable, which is categorical in nature, right? So this is mainly used for classification. So to define logistic regression for you, logistic regression is a method used to predict a dependent variable, y, given an independent variable, xdev, such that the dependent variable is categorical, meaning that your output is a categorical variable. So obviously this is a classification algorithm. So guys, again, to clear your confusion, when I say categorical variable, I mean that it can hold values like 1 or 0, yes or no, true or false, and so on, right? So basically, in logistic regression, the outcome is always categorical. Now, how does logistic regression work? So guys, before I tell you how logistic regression works, take a look at this graph. Now, I told you that the outcome in a logistic regression is categorical, right? Your outcome will either be 0 or 1, or it will be a probability that ranges between 0 and 1. So that's why we have this S-curve. Now, some of you might think that why do we have an S-curve? Right, we can't obviously have a straight line. We have something known as a sigmoid curve, because we can have values ranging between 0 and 1, which will basically show the probability. So maybe your output will be 0.7, right? Which is a probability value. If it is 0.7, it means that your outcome is basically 1. So that's why we have this sigmoid curve like this. Okay, now I'll explain more about this in depth in a while. Now, in order to understand how logistic regression works, first let's take a look at the linear regression equation. Right? This was the linear regression equation that we discussed. Y here stands for the dependent variable that needs to be predicted. Beta naught is nothing but the y-intercept. Beta 1 is nothing but the slope. And x here represents the independent variable that is used to predict y, right? E denotes the error in the computation, so given the fact that x is the independent variable and y is a dependent variable, how can we represent a relationship between x and y such that y ranges only between 0 and 1? Here, this value basically denotes probability of y equal to 1 given some value of x. So here, basically, this PR denotes probability, and this value basically denotes that the probability of y equal to 1 given some value of x, right? This is what we need to find out. Now, if you wanted to calculate the probability using the linear regression model, then the probability will look something like p of x equal to beta naught plus beta 1 into x, right? P of x will be equal to beta naught plus beta 1 into x, where P of x is nothing but your probability of getting y equal to 1 given some value of x dv. So the logistic regression equation is derived from the same equation, except we need to make a few alterations because the output is only categorical. Alright, so logistic regression does not necessarily calculate the outcome as 0 or 1, right? I mentioned this before, only instead it calculates the probability of a variable falling in the class 0 or class 1. So that's why we can conclude that the resultant variable must be positive, and it should lie between 0 and 1, which means that it must be less than 1, right? So to meet these conditions, we have to do two things. First, we can take the exponent of the equation, because taking an exponential of any value will make sure that you get a positive number correct. Secondly, you have to make sure that your output is less than 1, right? So a number divided by itself plus 1 will always be less than 1. So that's how we get this formula. First, we take the exponent of the equation, beta naught plus beta 1 plus x, and then we divide it by that number plus 1. So this is how we get this formula. Now, the next step is to calculate something known as the logit function. Now, the logit function is nothing, but it is a link function that is represented as an S-curve or as a sigmoid curve that ranges between the value 0 and 1, right? It basically calculates the probability of the output variable. So if you look at this equation, it's quite simple. What we have done here is we just cross-multiply and take e to the power beta naught plus almost beta 1 into x as common. Right. The RHS denotes the linear equation for the independent variables. The LHS represents the odd ratio. So if you compute this entire thing, you'll get this final value, which is basically your logistic regression equation. Your RHS here denotes the linear equation for independent variables, and your LHS represents the odd ratio, which is also known as the logit function. So I told you that logic function is basically a function that represents an S-curve that ranges between 0 and 1, right? This will make sure that our value ranges between 0 and 1. So in logistic regression, on increasing this x by one measure, it changes the logic by a factor of beta naught is the same thing as I showed you in linear regression. So guys, that's how you derive the logistic regression equation. So if you have any doubts regarding these equations, please leave them in the comment section and I'll get back to you and I'll clear the doubts. Right, so to sum it up, logistic regression is used for classification. The output variable will always be a categorical variable. We also saw how you derived at the logistic regression equation, right? And one more important thing is that the relationship between the variables in a logistic regression is denoted as an S-curve, which is also known as a sigmoid curve. And also the outcome does not necessarily have to be calculated as 0 or 1. It can be calculated as a probability that the output lies in class 1 or class 0. Right, so your output can be a probability ranging between 0 and 1. That's why we have a sigmoid curve. So I hope all of you are clear with logistic regression. Now, I won't be showing you the demo right away. I'll explain a couple of more classification algorithms. Then I'll show you a practical demo where we'll use multiple classification algorithms to solve the same problem.